Hi, welcome to another lesson with Dr. Hill. Today we're going to talk about the uses of the alkanes, the general, mostly everyday uses of the alkanes, and we're going to try and do it in less than 10 minutes, as usual. So we've already examined the physical properties of the alkanes, looking at their boiling point and their melting point, and we've learned that the lower number carbon chains, the ones that we've been talking about, methane, ethane, propane, butane, are gases at room temperature. And then when we get into pentane, we're getting towards a liquid at room temperature. And hexane is certainly a liquid at room temperature. So what use are these things? Why are they so important? And they're important to us because they are very combustible. You can burn them easily and you can create heat and light from them. And so they're used as fuels, and they've been used as fuels for a long time. Methane, for example, is natural gas. Methane and ethane is generally a mixture of the two. It's natural gas. It's lighter than air. So it's what we call natural gas, and it's the gas that's used to pump around big cities in gas mains and pipes that go through the cities. The reason that those particular alkanes are used is because they tend to be lighter than air. So a lot of the big cities have cellars in their buildings. If there's a gas leak with a heavier gas, it would fall into the cellars, and then you'd be building up a hugely inflammable gas in the cellar of buildings. So that's not desirable. So the lower C number alkanes, methane and ethane, are used as natural gas for piping gas around buildings. And that means that gas can be piped directly to your stove in the kitchen, and you don't have to worry too much about a gas leak because the gas will float up through the ceiling and through the roof. Nowadays, with better insulated houses, it is again a little bit of a problem. But the point is, it's lighter than air, so it floats away. The next one up, propane, is the gas that's used, is the alkane that's used in bottled gas. So if you go around and you see more in the country where gas mains don't reach, you'll see bottles of gas outside people's houses. Now they keep it outside the house because this one, if it leaks, it's heavier than air, it sinks, and it can sink into gutters, so you have to keep it away from that, and it can sink into cellars as well. So traditionally these bottles of gas are kept outside, and of course a big bottle of gas is a dangerous thing anyway, so keeping it outside is a good idea. And propane is used for domestic cooking and heating. And it's the bottle gas that you see being carted around in big bottles around the roads. The next one up, butane, is kind of interesting because it's a heavier gas again, and it's getting close to being a liquid at room temperature, which means it can be compressed only slightly and it becomes a liquid quite easily, and it's quite useful as a method of heating camping stoves. I've got a bottle of it here, so you see, you buy this stuff. This is camping gas, and this has got butane in it, and if you shake it, it's mostly liquid because this easily compresses to a liquid and is a little bit safer to carry around compressed as a liquid than it is as a gas. It also has a reasonable amount of energy and burns well. Now, these low carbon number gases of the alkanes are useful for burning because they burn really cleanly. Let's just have a quick look at I'll just show you one more thing. When we get up to really high numbers of carbons in the alkanes, we get to solids. And these solids are also fuels and also useful as fuels. And in fact, I have one here because this is a tea light. See, a tea light? It's what you buy to put in your little tea light holders as little candles around the house. They're very handy. And this is paraffin wax, and paraffin wax itself is an alkane. This has a carbon chain in the region of 28 to, I've lost my little wick, 28 to 35 carbons in the chain. But again, it's an alkane and a hydrocarbon just made of carbon and hydrogen. So let's have a look at the desk and have a quick look at the reactions because these are kind of important. So the uses of alkanes, they're used as fuels. So here's the combustion reaction for methane. So that's methane. And when you set fire to methane in the presence of oxygen, it burns to form carbon dioxide and water. And this makes it an excellent fuel. It's a very, very clean fuel, as you can see. It burns, it produces carbon dioxide and water. Carbon dioxide is non-toxic, although it has some environmental issues. But it's also a fertilizer for plants, don't forget that. We need it for photosynthesis. And water, which is completely non-toxic. Now, this makes these very safe fuels for using because they burn well with small amounts of oxygen. As we go up in the carbons, we find that the combustion is more difficult because the fuel has much more energy in it and it requires much more oxygen to make it burn. So there's not that much oxygen in the air. So when we burn a tea light, for example, it burns very slowly and it burns with a yellow flame. That's because it's burning incompletely. Instead of forming carbon dioxide, which is a nice safe gas and non-toxic, it forms another gas called carbon monoxide, which is very toxic, which you have to watch out for. So, but because these things are so small and they're burning so slowly, they don't produce very much. Okay, so to summarize, natural gas is methane and ethane. This is the stuff that's piped around houses in big cities. Bottled gas is propane. This is the bottles that most people use in the country for their domestic cooking and heating. And camping gas, this stuff here, is butane. In fact, you can see it says butane on the top. So, and then our paraffin wax is an example, C31H64. That is an alkane with 31 carbons in the chain, and it's used for making candles. There you go. So that was a quick summary of the alkanes and their uses in combustion. What you might want to try and do is write the balanced equations for ethane and propane and butane as a bit of practice. They'll all produce water and carbon dioxide as products. Once we get into higher alkanes, remember we're producing carbon monoxide because the oxygen can't be supplied fast enough to the flame to the fire, so to the combustion reaction, so it becomes more toxic. Okay, well, I hope I managed to do that in 10 minutes, and I'll see you in the next lesson.